Or I might just have to do it with the computer.
Yeah, that's fun to prop it up.
Or
Is that
or
bucket
we can
being
see
used?
we can see if we can go into the Zoom. Oh, let's go.
Yeah. No way.
Okay, this is what we're gonna do. This is what
Yo,
we're gonna do.
we
I'm gonna join on my
outside.
phone, and then yeah.
We outside. That's not. I hear the geese in the live stream. Oh yeah, yeah, probably.
Oh shit! How'd this come off?
Yeah. And what is the live stream on your phone? Is it up for live? Yeah.
How we doing?
Testing 1 2 testing.
We're live?
Yep. Can you hear? Can you
Live.
hear?
Is anybody watching?
There's a delay. It's probably not. How much is the delay?
Yeah.
One.
Woohoo!
Let's
go!
Let's go. Oh, wait, how long is the delay? All right, I just heard you talk now. Okay. Owen's walking over right now.
So can you control
It's really late.
which camera it's on?
Yeah. So we can have 2 cameras if you want.
Hello. My name's Owen. Welcome to the IrishSat launch of our payload that is called Iris 2.0. Yeah, this mission is all about collecting solar data for a professor on campus named Dr. Bernstein. So we have our payload. They're working hard on it right now, just making some hopefully last minute changes. We have our helium tanks over here. I don't know if you can see them. We'll make sure and give you guys live tours of everything. So stay tuned. Hopefully launch will be around 8:15, 8:30. With that, I hand it over to the trusty live stream crew. This is Kyle. This is Ryan. They're gonna be your tour guides. They're gonna be interviewing people, taking it around, saying what's up. Kyle, do you want to come say anything real quick?
Oh yeah.
As project manager, chief engineer.
Hi everyone. Good morning. Thank you for joining us. It's going to be a good launch. Just going to get it ready. Going to hopefully fill this balloon up here in about 40-45 minutes. Stay tuned and enjoy it. Thanks, guys.
Awesome. So like Owen said, I'm Kyle.
I'm Ryan.
I'm a freshman, aerospace engineer, and given this is my first year, it's been an exciting year to say the least. We launched in Iris last year. We got pretty good data, or we tried to get pretty good data. It was a successful launch, but we had some difficulties, so that's why we're running it back this year.
I'm a sophomore physics major, but I actually joined Iris this year, so this is new to me too, pretty much as what Kyle was saying. I mostly worked on the parachute, so I was just figuring out descent speed and all those things. We can go over that more later, but I'm new to this as well.
Yeah. So the purpose of IRIS is to test out some nano antenna sensors under Dr. Bernstein's research team. Dr. Bernstein is part of the electrical engineering department here at Notre Dame, and the payload has two cones on it, which will track sort of the light as we go up as a function of altitude, and basically that's what we're trying to do with the payload. Like we said, we're using a high altitude balloon. That's how it's going to get up into the air. You want to expand more on that?
Yeah, so the high altitude balloon is going to be filled with a certain amount of helium. They'll go over that. But so we fill up the high altitude balloon. Helium rises in the atmosphere. The balloon will expand. And once it gets up to about 30 miles,
100,000 feet.
100,000 feet, I think it was about 30 miles. That sounds right. Yeah, because like 30 kilometers. Yeah. So it'll get up to about 100,000 feet. That's a better way to describe it. And then the high altitude balloon will pop because the helium molecules inside will have expanded the balloon so much to the point where it'll just burst. And then it'll fall back down. Do we know where it's landing today?
Near Fort Wayne. So we have a team in a truck that's going to go retrieve it and then bring it back. Hopefully it's successful. Hopefully it doesn't drift too much off course like it did last time. But right now, we'll take you over real quick and take a look at what the team is doing. So right now we have two tarps. Our first tarp over here is the main payload, where they're currently setting up the Raspberry Pi, which is our main computer system. It's going to control basically all the functions, and it's going to store the data. And then over here, we have our helium set up. Right now, they're working on the balloon setup. As you can see, amazing. As you can see, there's two boom systems, which are these carbon fiber arms or rods. So there's one right here and then one on the main payload. So those will be, this one right here will be above the other one and then attached to the balloon. This allows for stability and also allows our bottom area or our bottom payload, which is actually holding the research data, to rotate.
It's important to have the second boom system significantly above the lower payload because of the two cones that are collecting our solar data and the background data of space, because you need to take the solar data and that's going to come with data that isn't the sun. And so if you take the background on the other side, so if you can see, let's take this over there. As you can see, we got these two cones covered in green tape. The one will be questioned. One of these will be rotating back and forth, trying to find the sun. There's a code running through our computer system, which turns that bottom plate. And when one of the cones locks onto the sun, the other will be pointing away from it towards space. We take the data from the sun, plus the little bit of background data it comes with, subtract out the entire background data we take from the other cone. And that's how we find the actual data from the sun that we're looking to find for Professor Bernstein. And so it's important to have the upper payload rise, especially above, so that there's no interference with the cones from the strings that we've got laying on the ground, the balloon above, just so that the data can be taken reliably and we can avoid obstructions.
Let's go talk to two of the members from the stock team and computing team on IRIS. Sorry to put you guys on the spot. You introduce yourselves and what your role is on IRIS.
I'm William, team lead of IrishSat.
I'm Isaac Bray. I'm just a systems engineer. I help out a lot with the comm stuff, so I work closely with Zach and Ambrose, the comms leads. I'm also on the chase car today, so after the balloon goes up, we'll be driving a little antenna on our car, tracking it down and pulling it out of some trees. So,
yeah. What was your guys' favorite part about working on IRIS this year?
My favorite part is probably the people. People are super awesome. It's inspiring to be around. and just the overall atmosphere of launching, they're building and launching an actual satellite going up. It's exciting stuff.
Yeah,
Like being inspired.
it's very fulfilling being around a lot of motivated, smart people. It's just a great environment, and everyone wants to, lift you up and teach you new things, especially as first years. It's a really great experience. So, yeah.
Thanks, guys.
Thank you.
More likely that it's a cable than actual.
I was talking about that.
I'm saying it's more likely that it's red.
Jackie, would you like to give an interview on your role in stock? Yes.
Okay. I was like, I don't think I have a choice.
Yeah. Can you describe what stock is and your role in stock?
So structures, thermals, orientations, and controls. I basically do all the stuff. So it's just the building stuff, the manufacturing stuff, designing stuff, making CADs. So it's a lot of hands-on work usually.
Wonderful.
Is that it?
Yeah, pretty much. How exactly does Iris rely on stock and everything that it does, and how does it work running the team and all that?
First off, it was a lot of like CAD, just like doing the setup of everything, and then we had to manufacture the parts. So going into the EIH, using the water jet, using the lathe, and just basically just getting stuff done. And it takes a long time to construct the whole thing. But
Yeah.
And then also installation. That's my job
Someone
currently,
does a
but I
portable
can't finish the installation.
hotspot.
So
All right.
here for the-
Yes, and no password.
Thank you, Jackie.
Seems
Guys, I don't know if this matters, but this is
seems like name and password.
That seems
No, I think it'll work. Let me try.
So it's saying recording in progress right in the middle of it.
I serve it on the Zoom.
No option.
Want some updates?
Sure.
So, the weather in South Bend has been, we'll just say bad, for lack of a better word. So this is the first time we've seen the sun in probably, a good 2 weeks. There it is. What does that mean? Well, when you're doing solar research and, you're trying to lock onto the sun and you can't see the sun for 2 weeks, it's a little tough to actually calibrate your system. So the plan was we're gonna, calibrate the system on site early morning. Probably not the greatest idea, but here we are. We think we brought a monitor and a mouse to boot up the Pi since you can't connect in through Wi-Fi because we're in the middle of nowhere. Problem is the keyboard won't work. It's like there's a device error. We think the Pi might be a little chilly. Then we'll figure it out. So that's the update.
Owen, could you give a little explanation of how it tracks the sun?
Sure. So there's on one of the cones, there's a little camera that's connected to the Raspberry Pi, which is our flight computer. So basically what the camera does is it takes a picture of the sky and it goes, okay, where are my brightest pixels in that picture? We then do a bunch of denoising and stuff like that. So eventually, if we have the sun in the image, it's just going to show up as a bunch of white pixels and the background will be black. And then we draw a circle around that blob of pixels and we find the center of it, and that's where the sun is. And that will feed into a PID tuned system that moves the servos to point it at the sun.
Awesome.
Pretty cool.
And did you develop that PID tuning system?
Well, yeah, I did. We wrote the OpenCV code last year, and yeah, we've been just tuning the PID ever since. But all right, if you want to
Awesome.
get up close, I can run you through it. So this is the camera that I am referencing. So this cone is the cone that moves. So this cone will angle up and down, and this whole plate rotates 360. So let's get up close. So the goal is this one on the right is going to be looking at the sun. The problem with solar research in the atmosphere is you have to actually do the research in the atmosphere. So if you're looking at the sun, you're going to be looking at the sun, but also the atmosphere. So the reason we have two cones is the idea is this one is just looking at the atmosphere. This one is looking at the sun and the atmosphere. And you do some, sun plus atmosphere minus the atmosphere, and you just get the sun. At least that's what we think. Probably not that simple, but we're doing it.
What's this little tinfoil ball?
Tinfoil ball is so that's a radar reflector. That's an FAA requirement. You're supposed to have something that reflects radar on it, so that I'm guessing that planes can see it. Because pilots are notoriously curious. If they see something floating up, they're gonna want to go it. So we've also been releasing. We've released like these. They're called notice to airmen. Basically telling pilots stay away from this area at this time at this place. So that's it.
Awesome. Thanks, Owen.
I took the cable down. What did you say we changed? Yeah. Is the pie screwed down?
We could run it back to campus. Have we tried different?
Zach, you want to say a few words about the project?
Sure. I'm Zach. I'm the communications squad co-lead. I'll also be president of IrishSat next year. So on the IRIS project, I'm in charge of basically transmitting data and tracking our satellite. So we have one transmitter that sends out data like our GPS, our altitude, it tells the temperature, and we're gonna be able to access that data and track our balloon in real time. We've also got another transmitter that will transmit the data that Owen was talking about, the sensors that are looking at the sun and getting all the infrared data. And we'll be sending that back as well. And then we've also got a thing called a spot tracker on the balloon. So when it hits the ground and our antennas won't be able to transmit anymore, this spot tracker gets a signal from the satellites in the sky, and then we can determine where our payload is so we can go recover it and get all our data back.
Zach, could you tell us what the success of IRIS will mean for the future of IrishSat?
If this goes really well, we can use this in our proposal to NASA to get a CubeSat in the sky. So we can show them, look, we know how to transmit data. We know our sensors work. We know all our code is right to be able to track the sun and get this data back. So we have some good quality original research that we can provide them and show them that we can give them.
Awesome. Thank you, Zach.
Thank you.
And for the records, this is a crisp April 10th, 2022. It is chilly outside.
It's pretty chilly.
Yes, is that that's what you oh, we use the same we never got on the sun.
So if you can see, we are running our program with a sun tracker. So the program is searching for the sun, as you can see, with that one cone moving up and down with the camera. And the plate is rotating until it finds it.
Yeah, so there's the first part of the like camera thing is it says it says what value, like each pixel has a value associated, and so obviously the sun would hopefully be brightest. So you say, what is my cutoff? Because you have to interpret things in black and white typically. Yeah. Oh,
Let's go, baby.
All right, you know what? Let's just power it up.
I think we told that.
Woo! All right, cut power.
The sun is over there, so they're all excited because it's working.
Can somebody call Ambrose and tell him we got it? All right.
So as you saw there, it sort of went around in circles until it finally saw the sun. You saw how it sort of jittered back and forth and never really set on an exact position. That's what the PID tuning is doing. It's sort of going back and forth. Once it sees the sun, it's going to move a set position, and it's going to see the sun again and move back and forth. So even though we're never going to get an exact lock on the sun, it's always going to be pretty much on it the whole time, and that's pretty much all we need. It's also very helpful as we go up because we're going to be sort of moving around. Hopefully it doesn't rotate too much, but the payload is going to spin a little due to the wind and do the Gulf Stream. So if we can keep sort of that tracking on the sun, pretty close to the sun the whole time, then we should be good. That was our main struggle this morning. So hopefully we have it all figured out.
More about the jet stream is more of my area of expertise with the parachute. The issue that we were trying to sort with the parachute was figuring out what exactly was giving the most drag to the system. You don't really want a high altitude balloon like this sort of swing like a pendulum back and forth. It's not ideal for it to really swing or move.
You want to go over to the parachute?
Yeah. So the parachute actually is in a plastic bag right now. We're keeping it there just while everyone's working.
No, Ryan's got a fresh set of lipos in his pocket.
Yeah, I've got that. So yeah, back to the parachute. Parachute's in the bag. It's got a 1 meter diameter. That the diameter is used in an equation for drag to solve exactly what the descent speed will be, because we know the force. It's a force balancing equation. Essentially, you want the force of the gravity on the whole system to be equal to the drag you're seeing, so that as it rises, you want to have or when I apologize, when it's descending, you want the drag on the parachute to be about the same as the force of gravity, so that there's a constant velocity, because you don't want the parachute, you don't want the payload to be accelerating down towards the earth. We're looking for a 7 meter per second descent speed. So with the weight of our payload, it should be about 7 with a 1 meter parachute, 1 meter diameter parachute. That's what we are looking at right now. So it's just a smaller parachute. We'll show you more when we take it out of the bag. We're keeping it in there just so while they're working, we don't rip it or tear it. The jet stream, most of the drag on the scent is going to be due to the balloon. The balloon's going to expand to a really huge size. And so as it goes through the jet stream, you're going to see it just has a large surface area, which means that there's going to be more wind pushing on the balloon than there will be anywhere else on the system. So the parachute, we're just hanging it underneath. It doesn't really matter where the parachute is in this case, just because it's going to have a fairly negligible effect on the actual movement of the system in the jet stream, which the jet stream was our main concern. It's not going to be too terrible. The winds will pick up as we get closer to our launch time, but it should be fine until the jet stream. There's not going to be any real movement, ideally, because it's not super windy down here on the ground. It's only going to get a little bit faster as we head to launch. They'll go through the jet stream. There's almost no wind in the upper atmosphere above the jet stream, so that's not a concern. When the balloon pops, the payload will flip, the parachute will catch and drag, will start to be applied, and then the concern was when we get back into the jet stream, do we need to deal with the major drag on it affects the landing zone, whether or not the parachute is falling too fast, falling too slow. We wanted to see what exactly would be necessary. We used an online program to find out where parachute or our payload would be landing. And again, we just used the drag equation to solve that. Our descent velocity was 7 meters per second with a 1 meter diameter parachute. The only thing that we really need to happen is for it to catch, and that's a little bit of an unknown. Kind of relying on the payload not falling directly on the parachute, which was one of our other key concerns with how we're doing this system. But it's pretty similar to what we did last year. Iris 1.0 had the parachute sitting in a box on the lower boom system. We've streamlined it. We put it underneath. The paracord attached to the parachute is glued, epoxied, and it should. We'll show you more when we can take the parachute out.
So let's take it over closer to Iris. See, Jackie is shaking up some hand warmers. So the hand warmers are going to go into the box and insulation, hopefully to keep everything warm. One of the issues last year was the cold. The cold affected our servos and also the electronics inside. So hopefully our new and improved insulation and hand warmers will take care of that issue. Also, we see on the left right here, we have a GoPro wrapped in Mylar. Hopefully the GoPro will get us some good shots as we ascend, and then we'll be able to release that once we get it back. We hope we get it back, but yeah, we should get it back.
Yeah, we'll get it back. Yeah.
Let's head over here. So over here is the balloon filling area. Getting ready to fill it up with, or set up the fill-up station with the helium.
Tell about dangerous the helium is.
You wanna give us a little breakdown of how dangerous this can that Will is dealing with right now?
Apparently, one small thing goes wrong. The helium comes out. Helium comes out one end really fast. It's at 3,000 psi. If you send the entire canister the other way, turning into a missile, basically. You don't want to be on that.
And then Owen's car just explodes. So hopefully that doesn't happen.
That's why we have a safe procedure for it.
Exactly.
It's a lot of pressure. Literally.
Literally.
Oh man.
So is it gonna respond to that one?
Stand. The stand. Thank you.
So confused.
Oh, it's nice. Hey, Sid. What is it? I said you're ready to go. Yeah, that's
So the payload weight,
Installation prep work is underway.
I would definitely stand by
They're good for the lid. Should we start doing the lid stuff?
So we're all clear from the FAA. We have 100,000 feet of clearance all the way up the ceiling. Got the approval months ago. Second checkup a week ago. We're all set.
when do we want to power?
That's one semester. Hey Jay, how's it going? Could you introduce yourself and then give a few words maybe on the computing side of things?
Yeah, for sure. My name's AJ. So I've been working on the kind of computer vision aspects. So basically, in order to record good data, we need to find the sun and then point our sensor the opposite direction. So essentially what happens is there's like a camera and there's like a search algorithm. So it kind of goes 360 degrees.
When you're done. Yeah, when you're done.
So it kind of goes 360 degrees, pitches to, and it just finds like the brightest spot. And because we have a solar film over it, the only thing you'll see is the sun. We'll lock on to that spot. And then we have something called PID tuning, which just interfaces with the servos and helps us to kind of lock on and not overshoot the sun.
Can you explain a little bit about how PID tuning works?
Yeah, so I actually didn't write the PID tuning myself, but from what I understand, it's basically this method of kind of fine tuning the movement of like a motor so that you don't overshoot your target. So there are like quite a few different parts. There's like key, which is I think proportional, integral, and derivative. And so proportional just kind of gets you there. Integral helps counteract things like oscillation. You know, in the case where you're just kind of bouncing back and forth between like the two sides of an image. The derivative just helps with overshooting. They take things like previous air into account. So yeah, we that's kind of like the last part that we worked on. We did a lot of PID debugging last night, and yeah, we're excited to launch today. It's looks pretty good. It took quite a while to PID tune it correctly, but yeah, it's really nice. So,
Thanks, AJ.
yeah, of course.
We have an internal feeding system. You guys have
So they just installed new batteries from our previous time running this program. And so I believe they're just working to make sure the code works again and that the system's all fine. They're hot gluing now the cap over the power system so that we make it. Yeah. We will now speak to Connor about working with the FAA to achieve a project such as this.
Right now? Or? Okay.
So just introduce yourself, describe working with the FAA.
Yeah, so my name is Connor O'Brien, and I'm the project manager for this project. So one of the things we had to do was reach out to the FAA. It was a bit of a tedious, administrative process with that, but basically we had some contacts at the FAA that we had to let them know what date we were launching. We had to fill out a few worksheets to let them know exactly where we were launching from, what we were launching, and where we're projected to land. And then we had to send them projection maps like 5 days out, 2 days out, 1 day out. And then I also had to make a couple of calls and place a few, just like, I guess, official notices that we were releasing this balloon just so they keep everything organized up there in the sky. So it was definitely a very, very tedious process and a bit annoying, but we got it all worked out. So it was good.
All right. Awesome. Anything about the delays or the weather dealing with that?
So I mean, the weather in South Bend in the spring, I mean, it's not very, very nice. So we've had to push it off multiple times. We were hoping to get 2 launches in this semester, and it's looking like we're only going to get 1. But our plan is to get 1 in early next semester now. So hopefully in August and September, the weather would be a little nicer to us. A big thing that we had to worry about was cloud cover. That's another FAA regulation, is that we can't launch if there's more than 50% cloud cover. So in South Bend in the spring, it's pretty cloudy. The perma cloud's pretty strong. So it was pretty hard to get a day like that. But this morning, I mean, it's beautiful out. It's just a little cold, but other than that, it's very sunny and not that windy. So we're hoping that it's gonna go well as long as the electronics don't get too cold.
Awesome. Thanks, Connor.
Awesome. Thanks, guys.
All right, let's bring this back over to Iris. They're currently working on just making sure that the thermal insulation is all set up, covering the power system, because electronics, when they get very, very cold and high atmosphere, well, they break, and we don't want that to happen. So making sure to cover it. Not sure exactly what they're using for insulation off the top of my head. We can talk to Jackie again about that. Yeah. So right now they're just taping the box over. I think it's nylon that they're. Daisy, do you know what the insulation is, the material?
Just house insulation.
Just house insulation. Okay, it's house insulation is what we're using. It's got hand warmers on the inside to keep heat inside the box. Because once you seal it, it's much like a calorimeter where it's designed so that heat cannot actually leave the system. It's a closed system. There will be no heat transfer out, or it will be minimal. It's the purpose of the insulation box. Hand warmers make it hot in the first place because it's pretty cold out here already. As well, you need to be particularly warm, because I think even if it were 80 degrees or so, you have to be still pretty careful, because it can cool off pretty quickly, or it might not be as hot in there as you want it to be. You want to have an input of heat in the system, and that is the purpose of the hand warmers. And then obviously insulation is doing its job. The box is taped and hot glued together, and as you can see, the camera is still locked on the sun, which is now risen a little bit in the sky up there. Looking like it's going pretty well.
Spot tracker's working.
It's dirt. You can see over here on the left, over by our upper boom system, Connor and Caitlin are hard at work attaching our GoPro that we are using to record the entire flight for viewing later and seeing how things went, maybe ways we can improve it. We're not going to inflate the balloon just yet, I don't think, but the camera similarly has to be insulated, because the camera is an electronic, so if it gets up there in the atmosphere, it too will break. So it's covered in a reflective, looks like reflective box. Box. It's got a hand warmer on the inside, taped together. Don't believe it's super glued, hot glued, but that's our one GoPro on the upper boom system. We'll be recording the flight. Pretty exciting stuff.
It has still has they hot glue process. You didn't change it. Yeah, it's just that was just bad communication. We should have thrown it away. All right, shall we? Connor, yeah. Ambrose AJ. Yeah. How long? How long does it take to get GPS?
Oh, we can. Let's just show them the parachute real quick. Looks like we're gearing up to launch. Right there, that white little blob on the left, next to our friend's shoe. That is the parachute.
What's about the sun tracker?
There's the sun tracker. We don't want to walk in front of it. Black phone right there.
It's still pretty cool.
The one with the camera on it, that upper part.
this doesn't necessarily need as good.
Take the phone, move a little bit closer. Whoa. Yeah. So this is parachute one last time. Meter long in diameter.
We have 1, 2, 3, 4.
Pardon me.
Yeah, but I mean, like, it's not working.
Sun tracker.
It's still on too.
It's still on.
See, it's locked onto the sun, doing its job.
That was an awesome shot. I mean, it's like,
Was it?
It's like
I'm glad.
Dude, just start.
Watch out, Kyle. Don't walk in front of it.
It's like, I lost.
Caught you in 4K.
Why didn't you take it off?
This is the live stream, huh? Yeah. Here we go. All right, do I just kind of go?
Yep. Introduce yourself.
Hey, my name's Pete Harkins. I'm the project manager of IRIS. We finally made it out, so we're excited. It's been a long time coming. As project manager, I help along with Connor to kind of organize the different roles here. So kind of keeping the project on track and with scheduling, budgeting, and yeah, and I've been working close with the comms team. I'll be in the tracking car today, which is exciting. We'll be heading out in a couple of minutes, and just following the balloon across the great state of Indiana. So we're looking forward to it. Thanks for tuning in. Yeah, and go Irish. Go Iris.
Thanks, Pete. So are we getting ready to launch then? Pete?
Yeah, we're gonna fill the balloon pretty soon. Balloon's ready to be filled.
Okay. What are we finishing up here? So what they're currently working on is getting a GPS system or signal so that we can reach Iris, and obviously the chase car needs it so that they can track it down. I didn't show you earlier. There's another GoPro on the booms on the lower boom system. The upper boom system has a GoPro. The bottom also has a GoPro, so we can watch the payload literally when we get the camera back. But yeah, they're currently finding a GPS signal so that they can actually follow Iris, which is important, obviously, because you need to be able to get it back. It's projected to not go into any major city. That is illegal. You can't launch it, and you want it to land in a field. We run the risk of it flying into Lake Erie, but the winds look pretty normal today. Our online program shows us that it should be landing, I believe they said, Fort Wayne, or whatever it was said earlier. And things are looking pretty good. We just need the GPS signal, and we should be ready to fill up the balloon and launch Iris pretty soon. Super exciting. Beautiful morning. Wonderful work the team put in, putting us all together. We're thankful for you joining us.
This is Drew. He ran the live stream last year, so if you're joining us for a second time,
Have any questions about Iris 1.0? I can answer them.
Drew's currently working on bigger and better things. I'm talking about IrishSat's other project.
Sure. So, as I'm sure some of our listeners are familiar with, but IrishSat is working on developing Notre Dame's first cube satellite. So we have lots of testing and hardware and technology development programs like Iris here, but we're also laying the groundwork to building and operating our own satellites on campus. So I had the pleasure of leading a project this year that was developing an orbital and attitude testing facility called OAT Lab, as we like to say, or Goat Lab, whichever you like. So yeah, this was a great project that will allow us to simulate the microgravity environment in terms of the way that spacecrafts are oriented in space. So, unlike on Earth, when I, have my cup here and then I tilt it, it's going to fall to the ground, and also not stay in the same orientation. But if you're in space, that orientation is set just based off of, similar to the Earth, Newton's 3 laws of motion, but things are just a little bit different. So we were able to simulate that with an air bearing, and we want to measure exactly how we're oriented relative to some plane. And so to do that, we simulate Earth's magnetic fields as they would be outside of the atmosphere. And based off of those measurements, we're able to tell exactly what our orientation is. So there's a lot of hardware and electronics that go into that, as well as software to generate the right magnetic fields and simulate the orbital dynamics of what's going on. And so we kind of work tandem with another project that's developing a flat satellite. So this flat satellite has all your favorite parts the satellite has: a power system, a communication system, and most importantly, attitude control and determination system. So this will work in conjunction with our laboratory to get the ball rolling on some satellite testing next year.
We're gonna do a reboot. Can we do a reboot just on the PRS? Oh wait.
Yeah.
YouTube is working.
Oh, good.
I was watching at home.
That's good. Thank you.
750. There were 18 people watching.
Yeah.
I don't know.
All right, so are we gonna say this is
Exciting.
10-minute countdown no matter what? If it doesn't work in the next 6 minutes, we're gonna. How long is the spot for this? Oh, well, we just rebooted this CBS and PRS. I don't think so.
Happy birthday.
Thank you. It's your birthday?
Five.
Happy birthday, Professor.
Yeah, that's good. Birthday. That's what we're talking about.
Happy birthday to you. Happy birthday, dear Professor. Good singers here. Happy birthday to you.
What else you can do?
Good job.
With us.
Your camera doesn't seem that angled down. I can't tell.
Yeah, actually, it's
Oh, it looks pretty good. Watching it in real time.
Oh, and why are we holding it up?
I don't know.
No, the payload.
So there's antennas coming out the bottom. You can't rotate with the antennas coming out the bottom. Actually, no, we don't need the status. Oh. Yeah, make sure it's out of the way. Imagine if all these cables. The wind's blowing.
It's not like circles. Make sure you Jack, can you put the lid back on? Connor, you talking about these? You talking? I don't know. Is that the heater? Yeah. That's what I was doing.
Myself, Megan, Nathan, we're on solution. You got Drew, who's going to be here for the next over and hit anything. Crack can go with it, so it'll be okay. Once you go to the airborne, it's going to look at that bucket.
What is it?
GoPro's on.
Yeah, it would be.
A week.
No, I'm gonna do it.
Oh, and what's in that bucket?
So we just have a bunch of weight in there. So the way you tell when your balloon is done filling up is once it lifts up that bucket. And that bucket weighs about, it's like a 1.5 times the weight of our payload. Because if it weighed equal, it would just float there. You want it to actually accelerate. So our ascent rate is like 5 to 6 meters per second, which means we'll get up to like probably 27 kilometers in about an hour and a half.
Let us know when to just go get a.
How high is that?
Right now, they're setting up the hose on our helium tank. They're going to connect that helium hose to the neck of the balloon and start the inflation process. I'm going to turn it off.
What?
Turn it on.
Your brother's here. Let's go.
Yeah, exactly.
Oh, and should we start moving back to get?
Yeah, I would take a couple steps back. It's not very windy. What?
Let's go! Let's go! That's awesome.
That's so exciting.
Yeah, that is. I'm Owen's brother.
You're Owen's brother?
Yeah, Sid.
Good. Pleasure to meet you. I'm Ryan.
Nice to meet you, Ryan. I'm gonna put this on TikTok. Balloon launch, balloon going up, and then the launch. I'll put this on TikTok. I'll put this on TikTok, Ryan. I'll put this on TikTok. So
Great idea.
on my TikTok account.
What's up?
His phone's locked up.
Yo, Kyle. Your phone locked for some reason.
Nice tripod.
Your phone turned off, so it's still going though. It's unlock it. It's good. Yeah, it was going through the entire time. It just turned off.
Oh, okay. That's so strange.
I'm Owen's brother. Nice to meet you. Sid. Mm-hmm. Peter. Peter. So I want to put this on launch on TikTok. Yeah, it's awesome. On my TikTok.
So if anybody's wondering why there was a bit of a hold up there, we were waiting for our GPS tracker to get a fix. So basically they're orbiting GPS satellites, and our tracker has a little antenna that searches for a signal from like 3 or more satellites. And then once it gets that, then it has a GPS signal that starts sending this GPS data. So we were having trouble getting that. We had a bit of a delay, but we just recently heard some good packets over the radio, so we're going to be able to get on that. Awesome. Ambrose, what goes into the setting up of the GPS system and how it communicates with Iris?
We have two self-contained transceiver modules, and they're basically just meant for sending GPS data, and they're like pre-formatted, but we like hack the second one to send our own stuff. So we basically have so there's Dr. Bernstein's research was receiving signals into analog to digital converters, which gives us a digital signal. So it's in the Raspberry Pi. And on the Raspberry Pi, we have some functions in Python that we call that pull in that data, format it correctly, and then send it over an ITC connection, which ITC is just a communications protocol.
Awesome.
And it sends that to our transceiver, which reads in that data, puts it into the packet and sends it out. And then we can hear it over the radio. We have another system set up with the radio and something called a terminal node controller. The terminal node controller basically takes in audio data and it turns it into a digital signal and reconstructs your data so you can have it on your computer and analyze it, things like that. So saving all their stuff and then converting it back, doing a little math on it to pull out what we really want, and that's what we're ending up doing.
Awesome.
That's the whole thing.
Thank you, Ambrose. As you can see, the balloon is now being inflated. You got to go slowly so that obviously 3,000 psi from the helium tank. You don't want that to go straight into your balloon because that will rip it. Iris is being held up on the right side by some of our team. Left side is being inflated, as you can see, taking form. As soon as that bucket lifts up, we're going to know that the helium balloon is full, ready to be let go to the atmosphere. We here at IrishSat would like to thank you for joining us today for the setup and launch of our high altitude balloon, Iris 2.0. We're glad that you could join us. Got jitters.
Honestly, with no wind, we could probably raise it by 8 if that's the worst case scenario.
There's Caitlin on the right with the parachute, holding it up so that it doesn't snag on anything when this payload is launched, released.
It's so still.
It is very still. So you see, this is a slow process. You have to go a little bit slowly so that obviously if you went too fast, you'd run the risk. But there's all the hoses attached and you see the lines maybe. No, you can't really see them on the stream. But everyone's got to make sure everything's off the ground. You don't want to get caught on anything. And a single bit, gonna have to do detachments, and we're just waiting for that bucket to raise off the ground. They had to shorten the length of the cord the bucket's attached to because it looked like the hose wasn't long enough to compensate. So that's where we're at right now, just filling up the balloon. As you can see, there's almost no significant wind for now. Hopefully it stays that way. No random gusts as we're trying to get our balloon off the ground here. It'd be bad to get hit with such crazy abnormality. It's been really calm all morning. The wind speed I'm seeing is 1 mile per hour east.
Ideal.
Ideal. So you were introduced to Kyle and I for your live stream hosts. We've had another man behind the scenes, Peter, right here. Been helping us out a lot. Worked with the camera. He's been watching the live stream, making sure everything's being held together. Big team project. I'm gonna record this on my own phone. This is super cool. We have stopped the flow of helium to the balloon. Oh, no problem. You're good. So we're attaching to the second helium tank. Looks like the first one ran out on that balloon.
Hi, Bob.
We're going to fill the balloon again. I believe it should be full to about a diameter of 10 meters, if I remember correctly, and it should expand to about 50 in the upper atmosphere. So obviously it'll burst at some point because the plastic is just going to rip. That is due to the laws of thermodynamics that the pressure times the volume is equal to the moles of a gas times a constant times the temperature. And as it rises in the atmosphere, the temperature will decrease, but the volume will increase as the pressure decreases so that the system remains constant. As the volume increases to compensate for those losses in pressure and temperature, that is when the balloon will burst because the volume will be increasing and the decrease in pressure causes the particles of the helium to fly around in the balloon. Yeah. Not a super complicated process, but a very involved one. The bucket appears to be getting close to lifting. It hasn't lifted, but from my perspective, it looks like it might be shaking a little bit. It's beginning to rise. It is lifted barely off the ground. The bucket has lifted off the tarp. All right, the helium has been turned off. We need to detach the hose and we'll let Iris go. Yeah. I told him, but I don't think you can really see it because of the quality of the camera.
Just told him the guy with the bucket and so the guy was
Yeah.
Aerospace.
there you go. All right, you can go ahead and get on.
The hose has been detached. And they're just making sure they tie the balloon closed.
Oh, you can like work it out.
This is so much calmer than last year's launch. Have you seen the video? Yeah, it was like super windy.
I've seen the edited video.
Yeah. No, like
That's a good sign.
yeah, no, last time the balloon was flinging all over the place and yeah, not ideal.
It's a cool thing about the fluids. Like nitrogen, oxygen here, and then helium, super light.
Yeah.
Floats the surface of the atmosphere.
Right. That bucket is lifting.
Yeah.
Can't quite see it on the stream, but it is about 5 or 6 inches off the ground, maybe 4. Might partially be due to them lifting the payload, but obviously the helium balloon it's got a pretty heavy amount of helium inside. We're currently securing the straps, paracord.
We have a GPS lock.
We're going to remove the bucket.
Oh, yeah, listen to this.
And now we're playing Dropkick Murphys. True Notre Dame Irish fashion. Ideally, this won't go to Boston. But the song's good.
Yeah, it's parachute.
Let's go. Let's go.
Woo! There she goes.
Parachute's making me anxious.
Oh my goodness. And that is the launch of Iris 2.0, April 10th, 2022.
Hey, group picture.
Sit.
I saw him. Oh, you see him. I didn't expect this.
Let's go.